Alright, so continuing with the Chapter 13 practice test. I think we'll probably just do one of these because they're pretty much done the same way. So it says find cosine and tangent if sine is given there. I think the second one is a little bit harder, so we'll do number 4 instead. So it's always a good idea to start out by figuring out which quadrant we're in out of these 4. And we know that secant is negative. Secant goes together with cosine. So cosine is positive in the 4th quadrant and the 1st. That means cosine and secant would be negative in those two ones that I circled. And how do we decide? Well, we decide based on this. Cotan is positive, and cotan and tan have the same positive or negative value. So tangent is positive here, so that means we're in quadrant 3 right here. Okay, we're trying to find cosec and sine, and in the 3rd quadrant these are both negative. We know we're in the 3rd quadrant because of what we just said. Alright, so we're given secant, and how do we decide which identity to use? Well, if we're given secant, we're going to want to use the identity that has secant in it, which is this one. Sec squared is equal to tan squared plus 1. So we'll plug in secant of -2, and we'll try to solve this from here. So -2 squared is 4, and if we subtract 1 from both sides, we would get 3 is equal to tan squared. And then we'll square root both sides, and we'll get plus or minus root 3 is equal to tan. How do we know which one it is? Well, again, we said that we're in the 3rd quadrant where tan is positive, so that means tan is going to be negative root 3. So we'll keep that. That's not what we were asked to find, though. We were asked to find cosecant and sine. So we found tangent. Okay. If we need to find cosecant and sine, that means we need to use one of those other identities that they're given to us. Okay, and they give us a couple things. One of the other Pythagorean identities, what I meant to say. So they give us secants. We use that to find tangent. Here's actually what we should have done, and sometimes these things occur to you later on. We should have actually used this identity. We should have used the fact that sec is 1 over cosine, because if sec is -2, that means basically if you flip this around, you would get cosine. So cosine is going to be equal to -1 over 2. So yeah, that little digression of finding tangent wasn't really necessary, but sometimes you notice these things after the fact. So we know cosine. By the way, here's another way we could have told. We were being asked to find sine, and so we're going to want to use the identity that has sine in it, which is, move it up for a sec, which is this one right here. It's the one that we use all the time. So sine squared plus cosine squared equals 1. We just found cosine down here. It's -1/2. Okay, so we will plug this in. -1/2 squared is +1/4. So we're going to get this. If we subtract 1/4 from both sides, we're going to get sine squared is equal to 1 minus 1/4 is 3/4. Then we'll square root both sides. It's going to be plus or minus, but we know it's minus because we decided on that at the beginning. So sine is equal to -√3 over 2, and cosecant is the reverse of that, or is the reciprocal of that. Cosec is, if we flip this over, it's 2 over -√3, and we'll multiply both sides, top and bottom, by √3, so we rationalize it. So -2√3 over 3, that would be our cosecant. There's our two answers. Let's just do number 3 since it's here in front of us. Find cosine given sine. So that means since we're given sine, we want to find cosine, we're going to use this identity that has both of them in it. Okay, and let's decide again in our quadrant which quadrant we're in. So sine is positive 2/3. That means either in the 1st or the 2nd is where we have to be. Tangent is negative though, and tangent is negative in this quadrant. So we're in the 2nd quadrant where tangent is negative and cosine is -2. Okay, so let's use this identity. So sine squared would be 2/3 squared plus cosine squared, we don't know that yet, equals 1. So 2/3 squared is 4/9. And then if we subtract 4/9 from both sides, we would get 1 minus 4/9 is going to be 5/9. So we'll have cos squared is equal to 5/9. In the beginning we said it's going to be negative. So when we square root, I'm just going to put the negative there. Cosine is equal to -√5 over the square root of 9 is 3. So -√5 over 3 would be cosine. At least we found that much. So -√5 over 3. How do we find tangent? Well, we need to keep an identity in mind. Tangent is equal to sine over cosine, and we have both of those now. We have sine equal to 2 over 3. They told us that here. we just found cosine was negative root 5 over 3. And when you divide these, the 3's will cancel. You'll get negative 2 over root 5. And when you rationalize that denominator, you'll get negative 2 root 5 over 5. Sorry, that's a little bit messy, but here's what it looks like. Not so messy, negative 2 root 5 over 5. Alright, so that's section 13.1. 13.2 is on proving identities. So we'll do several of those. And there's actually a lot of these. I don't know if we'll do every single one, but we'll try to hit at least a bunch of them. Okay, so the strategies are we start with the more complicated side, and the more complicated side here looks like the left side. And the other thing is try to make well-known identities appear. That right there is an identity that says cotan squared plus 1 equals cosec squared. So if we subtract 1 from both sides, we would get cosec squared minus 1 equals this. So that's the same as 1 over, that whole thing is cotan squared. Cotan squared, 1 over cotan squared, that's another name for tan squared. And tan squared, when in doubt, change everything to sines and cosines. Tan squared equals that. And that is proven. We just proved that that's equal to each other. Okay, this one, take the more complicated side. They both look equally complicated, so that's not really going to help us. Try to make well-known identities appear. Okay, well, there's a lot of well-known identities here. There's a well-known identity with sec squared, which is this one, tan squared plus 1 equals sec squared. And I know that I want a tan squared to appear, so let me change this into tan squared plus 1. There's also a well-known identity with cosec squared. It's this one, cotan squared plus 1 equals cosec squared. So I'm going to change cosec squared into this, into minus cotan squared plus 1. And now if we distribute the minus, we'll get this, tan squared plus 1 minus cosine squared minus 1. Those will cancel, and we're left with tan squared minus cotan squared, and that is what we wanted to prove. So we're done. Alright, let's do a couple more here. So this one, actually 7, is almost the exact same as what we just did. It's actually the reverse, so we can skip it. This right here is the negative of sec squared minus cosec squared, and this is the negative of tan squared minus cotan squared, and we just proved this exact thing on the other page, so we'll skip it. This one right here, try to make well-known identities appear. This one, there's a well-known identity that has tan squared plus 1 equal to sec squared. So let's subtract 1 from both sides. So we get tan squared equals this. But here's the only problem. This is 1 minus sec squared, and this is sec squared minus 1. So let's factor out a negative 1. And this negative 1 will become positive, and this positive sec squared will become negative. So that means this thing right here, negative tan squared equals negative this right here. So we'll change this whole thing to negative tan squared. Tan cancels here, and one of those two tans cancels there, so we get negative tan equals this. Alright, number 9, take the more complicated side, that's the left side. Try to make well-known identities appear. This one is a well-known identity, we just used it. So tan squared plus 1 equals sec squared. We subtract 1. That means this thing is equal to tan squared, so I'm going to replace the bottom of this with tan squared. And we want it to equal this thing. Well, it's not actually that hard to do that. Tan squared is, we want to make a cotan squared appear, and these are reciprocals. So we know that tan squared equals 1 over cotan squared. So let's change that. We also know that cosine is 1 over secant. So we'll make that 1 over secant. We'll make this equal to 1 over cotan squared. And now we'll multiply this out. So 1 over sec times the reciprocal of that would be cotan squared. And cotan squared times 1 over sec is right there. So that's the proof. Okay, this one right here, take the more complicated side. That's definitely the left side here. The right side is pretty simple. And try to make well-known identities appear. Okay, well, let's think about this. There's a well-known identity that involves sec squared, and it's this one right here. I'm just trying to think whether this will work for us. We may as well try it. So that's a well-known identity. So let's write this as tan minus this thing, minus tan squared plus 1, because that's what this equals. That's an identity, times cotan. Okay, then let's distribute this. So we're going to have tan minus tan squared times cotan and then cotan times 1 would be cotan. I'm actually going to put this in parentheses because we have this minus that's going to have to be distributed. So tan minus tan squared cotan minus cotan, because the minus again is getting distributed right there. Alright, let's see what we can make out of this. So here's what we're looking for. We're looking for a negative cotan, and we have one right here, but we're not quite done. So tan squared, remember cotan and tan are related, they're like reciprocals. So tan squared is the same as 1 over cotan squared. And then we have this times cotan. We still have the minus cotan. So this will cancel, and one of those will cancel. And what's another name for 1 over cotan? Well, 1 over cotan, that's the same as tangent. So this whole thing is the same as tangent. You kind of knew that that had to be the case, because remember, we're trying to get everything to cancel except for the negative cotan. That's the only way to make that happen. So those cancel, we're left with negative cotan. And let's just verify that's exactly what we wanted to prove right there. So that is done. Okay, we'll finish 13.2 right here, and then the next part is 13.3. So 13.2, 2 more identities. Try to make well-known identities appear. And actually, in terms of 11, which one is the more complicated side? It's I would say the right side is more complicated. So let's think about this. When in doubt, change everything into sines and cosines. So let's try that. This right here is the same as 1 over cosine. So we're going to have 1 over cosine times this thing, times the reciprocal of that thing, I should say, which is 1 over sine squared cosine. And what is this going to become? Cosine times cosine, that would be 1 over sine squared cosine squared. Okay, and then we can change that. 1 over sine squared is cosec squared, and 1 over cos squared is sec squared. So that's, this thing is equivalent. And we somehow have to make that equal to these things being added together. And it's not necessarily obvious how to do that. So when in doubt, change everything into sines and cosines. We kind of already did that. That's not going to help. So this might be an example of a good place where we can have things meet in the middle. So we could start changing the left side, but I think what would be better actually is to do this. We'll try to use one of these well-known identities. So this sec squared, there's a well-known identity that involves that. It's this one right here. So let's try this one. And by the way, the reason I'm doing this is because we have a plus right here, and we need to see how can I make a plus appear right here. If I change it to plus, then at least it's apparent how that's going to work. So we have 1 plus tan squared. Let's distribute. Well, this is good because cosec squared times 1 would be cosec squared. So that covers this part at least. And then plus cosec squared times tan squared. We're going to have to simplify that by changing things into sines and cosines. So let's try to do that. So we'll have cosec squared plus this thing is 1 over sine squared. This thing is sine squared over cos squared. And those will cancel, and we're left with 1 over cos squared, which is equivalent to secant squared. So cosec squared plus sec squared, let's verify. And that is exactly what we have, so that's what we wanted. Okay, this one right here, take the more complicated side, and that looks like the left side is more complicated here. So let's do that. Let's change the left side, and when in doubt, change everything to sines and cosines. So I'm in doubt here, so let's change this thing into 1 over cos squared, and that was a good decision because those will cancel. And we'll change this thing into cos squared over sine squared. We have 1 over this thing. That's the same as 1 times the reciprocal of the bottom. And that's just going to be the same thing. Sine squared over cosine squared, though, equals tan squared. So now we need to make a well-known identity appear, and that's this one right here. Because again, how did I know to do this? I'm looking at this side, I see a sec squared. On the right side, I see or left side, I see a tan squared. I know that those are related. So tan squared, if we solve this right here for tan squared, we do minus 1 from both sides. So tan squared is equivalent to this, and we're done. We just proved it. So that is up to section 13.2 on proving identities. In the next video, we'll talk about finding sum and difference.